Let's start our exercise 2.2. In this we have to verify the relation. So first of all we have to factorize it. When we factorize it we will get plus 2x minus 2x. So we have to factorize in that way that the sum is minus 2x and the product is minus 8x square. Now from the first two terms we have to take the common. So here we had taken x as a common, and from the next two we had taken 4 minus 4 as a common. So we will get x plus 2 within the bracket, and the other two factors will become x minus 4 and x plus 2. So the value of x will be is equal to 4 and other value is minus 2. These are the two values of x, that are the zeros of this polynomials. Now we have to verify the relationship between zeros and coefficient. So first equation is we have to verify the sum of the zeros. Same formula, we have to add these two values. Sum means we have to add. Then the formula is minus coefficient of x. So coefficient of x is minus 2. We have to include the sign also. Here the sign of 2 is minus and 1 minus is from the formula. And the x square, the value of coefficient of x square is 1. From here if we solve, we will get 2 is equal to 2. Here we will get 2 is equal to 2. Hence this thing is verified. Now we have to verify product of zeros. So to verify the product of zeros, again we have to multiply these two values, and we will get constant term is minus 8 and the coefficient is again the same 1. So if we multiply 4 by minus 2, we will get minus 8, and minus 8 is equal to minus 8. So these relations are verified. Now move to the next question. 4s square minus 4s plus 1. So here the variable is s, not the x. So it doesn't matter, variable can be anything. So we have to factorize it, and from the first two term we had taken 2s as the common, and we will get 2s minus 1 within the bracket, and from the next two term we have to take minus 1 as a common, and we will get 2s minus 1. So the factors of this equation will become 2s minus 1 and 2s minus 1. So the value of s is equal to 1 upon 2. So two values of s we will get the same, that is 1 upon 2. You will get two values of s and both are equal, that is s is equal to 1 upon 2. Now we will have to verify the relation, that is sum of zeros is equal to minus coefficient of s and upon coefficient of s square. So sum of zeros is equal to half plus half is equal to minus, and coefficient of s is again minus 4 and divided by coefficient of s square. Now here the coefficient of s square is 4. Half plus half is equal to 1, and minus minus will become plus, and we will cancel out 4, so it will become 1 is equal to 1. So sum of zeros equation will verify. Now we have to verify the product of zeros. In this we have to multiply half, and the constant term is 1, and the coefficient of s square is 4. Half multiply half, we will get 1 upon 4 is equal to 1 upon 4. Now move to the next question. 6x square minus 3 minus 7x. In this this is not a standard form to write the equation, so we have to write the equation in that form. This is the standard form to write the quadratic equation. So now we have to factorize it and make it 7 into two parts, so that if we add we will get minus 7, if we multiply these two we will get 18x square. So from the first two terms we will get 2x as a common, and within the bracket 3x plus 1, and the next two we will get minus 3 as a common, and within bracket it is 3x plus 1. So the two factors of this polynomial will be 2x minus 3 and 3x plus 1. Now we have to find the value of x. Same steps. X is equal to 3 upon 2, and from here x is equal to minus 1 upon 3. Now we have to verify the relation with these two values. So we get two values of x, and we with the help of this sum of zeros expression we have to verify it. So the two values is 3 upon 2, and we have to add plus minus 1 upon 3, and the coefficient of x is again minus, so we have to put it in bracket and upon 6. The coefficient of x square is 6. So we have to solve this by LCM method, and we will get here it is 9 and minus 2, and if we solve this minus plus 7 by 6. By subtracting 9 minus 2, we will get minus 7 upon 6, and in the right hand side we also get 7 upon 6. Similar way we can solve for the product of zeros also.